Hello, everyone. Welcome back for the last talk of the day. We have our keynote speaker, Fernanda Viegas, who will talk about data visualization as an exploratory medium from scientific insight to artistic expression. So we'll get a bit artistic as well. So Fernanda is currently part of Google Brain, and she co-leads the Google Pair initiative. She used to work a lot with Martin Vanderberg, and she always focused on the human-AI interaction with the purpose of democratizing AI technology. She has a PhD from the MIT Media Lab, and yeah, we're very curious to see what she will tell us about data visualization today. So Fernanda, you have the floor.
Great. Thank you so much. Thank you, Christina, for the introduction, and thank you for having me. I'm very excited. So we're going to be talking about data visualization, which is one of my favorite topics. And what I'm hoping to give you today is just a sense of how broad data visualization is and how really I think about it as a medium, an expressive medium where you can do very serious things like science and activism, and you can do very expressive things like art. And so let me just tell you a little bit about my team. As Christina mentioned, I co-lead the PAIR initiative, which stands for People Plus AI Research at Google. We do use data visualization to look at AI systems and try to better understand how these systems are working. This is my wonderful team. Martin Wattenberg and myself co-lead the team on the Google Brain side. And today, what you're going to see are some of the projects that Martin and I did together, maybe even before we joined Google. So let's just take a step back very quickly and talk about data visualization. So what is it? What is it used for? Why do we want to use this technology? So data visualization, very simply put, is turning information, usually numbers, but not always, as you will see today. There is more to data visualization than numbers. So we turn some kind of data into images, okay? And you can imagine like a very simple example that everybody can relate to in terms of data visualization are maps, right? Maps are visualizations of a lot of information that are geographically placed. Why do we want to visualize data? It turns out because data visualization takes advantage of innate capabilities we have. So we are amazing pattern-seeking machines. And when I say pattern, I mean visual patterns. A significant portion of our brain is actually wired for the visual system. And so it feels like we're not even making an effort, and we're immediately picking up patterns, sometimes very complex patterns about the world, visually, seemingly even without making any effort. So wouldn't it be wonderful if we can take advantage of that innate capability we have in order to digest massive amounts of data, okay? Data visualization also has what I think of as a distinguished history. And luckily, some of my biggest heroes in data visualization, actually one of them is a woman, Florence Nightingale, whom you see there. She was an English nurse and statistician, and she used data visualization to impress upon the British government how much soldiers were dying in the Crimea War, how much more soldiers were dying in the hospitals than in the battlefields. And why did that matter? It mattered because the point she was trying to make was that sanitation and hygiene in hospitals was a crucial thing that nobody did back in those days. And so therefore, a ton more soldiers would die at the hospital. And so you had to clean that up. And you had to come up with new methodologies and new techniques for dealing with hygiene in places like hospitals. And it was because of that and a lot of it because of this data visualization you see here. It shows deaths of soldiers over time. That's what she's showing there. That today, thankfully, we have much better systems of hospitals and clinics where we don't feel like we're going to die if we go there because of lack of hygiene, right? And so she's one of the pioneers of using data visualization to really make a difference in the world and really change things, use data to change the state of the world. The fellow you see right next to her is William Playfair. He is one of the pioneers also who created a number of techniques that we use up to this day. The chart you're looking at there looks at the trade balance in England over time. Another part of the history also involves activism, social activism. So we have on the left there, W.E.B. Dubois, who used data visualization to impress upon not only the US, but also the world. These two charts here were made, if I'm not mistaken, for the Paris Fair in 1900, about the number of free African Americans in the US and the state of their living experience back then. They were free, and yet there were all sorts of inequities, right? And one of the things that I think is super interesting about his work is that not only was he very pointedly showing inequity, social inequity, his charts are beautiful. They are just aesthetically speaking very impressive, and some of the charts he created nobody had seen before, so please look him up. And then the fellow on the right is John Snow, who actually was a doctor, an English doctor, and he figured out that cholera was in London. So this is a map of London, and he just started. Cholera was an epidemic. Tons of people were dying. They couldn't figure out how it was spreading. And so he just started visualizing, marking on the map where the deaths were happening in this region of London. And because of this map, he realized that chances were that there was a water pump that was making that around that area, that where somehow these deaths were related to the water pump. And so they had the city turn off that water pump, and things became much, much better. So again, understanding the link between cholera and its not only the symptoms, trying to treat the symptoms, but trying to get to the cause. And the visualization was key in making that happen. Visualization today, obviously, is incredibly dynamic, right? And so I have a few examples here of newspapers. So the two examples on the right come from the New York Times, and the example on the left comes from El País in Spain. And one of the things that I think is incredibly important in the fact that today we have data visualization for regular readers, right, is that we are at a time when so much of the world around us is captured by data, and a lot of times complex data. And there was a time when newspaper editors didn't feel like they could expose their readership to tons of numbers. In fact, journalists would be told things like, oh, you have too many numbers in your article, or no, nobody's going to follow this. You need to simplify. Well, data visualization allows you to bring hundreds, sometimes thousands of numbers to your readership in a way that they can relate to and they can digest without having to have a PhD in math or in statistics, right? And that's super important. It's very important because you want these consumers of data. You don't want only the statisticians and the mathematicians in the world to be able to consume complex data. You want regular people to be able to understand the world around them in more complex ways. And so I find it fascinating and really exciting that even during my career in data visualization, I've already seen a major change of how much complex data the regular viewer is exposed to these days versus, say, 10 years ago, 15 years ago. All right, so now that I talked about a lot of things in history. And now I'm going to talk about my own work. And this is work I did with Martin Wattenberg before we were part of Google. So this was early days of Wikipedia. To the point, it was very early days, to the point where nobody understood what a wiki was, or let alone how Wikipedia worked. And yet, one of the things that was very interesting was to try to understand is how are people coming together and making use of this website to create really valuable articles. And so we decided we wanted to visualize Wikipedia, but we weren't sure how to do it. So we started looking at Wikipedia. So this is a vintage screenshot of Wikipedia back in the 90s. And no, 2000s, sorry. And this is an article about chocolate. And one of the things we realized quickly was that every article on Wikipedia, in addition to the article page, you also had a page like this, which was the editing history of the article. So this was the log where you could find everything that had been changed about the article, who changed what, if they left a comment, and so forth. And each article can have like tens or hundreds or even thousands of pages like this, right? So it becomes really big. And this is exactly the data we decided to visualize. We're like, oh, this is where the action is. People are adding things, they're taking out things, they're changing things on the text. So here we decided to visualize both the text and the dynamics of collaboration. So this is what we did. We created a new technique to do this. Imagine, and I'm just going to show you an example of the technique, and then we're going to jump into Wikipedia. Imagine you have a document that is being edited by 3 people, okay? Mary, Suzanne, and Martin. And I'm going to color each one of these people in a different color. And you have each version of the document is colored by the author. So Mary started version number 1, and the length of that line is the length of the document Mary created. And then version 2, Suzanne comes along and says, this is great, I'm going to add a little paragraph to the bottom. And I can see that because I have a little bit of a line in Suzanne's color in blue. And then version 3, Martin comes along and deletes some of the initial text and adds his own text and so forth. So you have different versions and they start to be colored by the authors, right? To make things even more clear, what we do is we connect the pieces of text that survive, that stay the same over time. And so you have these polygons and you can see things being added, things being taken out, and so forth. And notice how right now I'm visualizing each version equidistantly, right? But I can also start playing other games where I can visualize the same thing, the same information in real time. So now I have a rhythm on my screen, and I can see that, from version 1 to version 2, a long time passed. But between version 2 and 3, it was really fast. So you can start to get a sense of rhythm. I can also highlight whatever version, and I can show the actual primary data set, the text itself, colored by the author. Okay, so now let's see this in action. Are you seeing a video right now? Okay, I hope you are. So on the left here, these are the authors who have touched this article. This is the article on design. On the right, you have the text of the article itself. I also have a wand that I can play with. And as I move my wand around, you can see how the text on the right changes. Each one of these vertical lines is a version of the text. Now let's look at something more interesting. Cat. So many more people like cat than design on the web. I know that because I have much more authors. I have many more versions. And the article is much longer, the article on cat. Okay, I also have some interesting patterns, like this stripy green and kind of brown pattern. And what that is a table that someone added with the class for cats and the kingdom and the family and the the species and so forth. I also have this antenna at the bottom where someone added a bunch of paragraphs about the cat, the Unix command cat. And the next time someone redirected that entire set of paragraphs to a cat Unix page, okay? Now we're looking at abortion, and it's a very long article, as you can see there, but I have some interesting patterns. I have these gashes, these black gashes that are showing there. If I go there, what I see is that it's a mass deletion. Someone just deleted the entire article. Here they deleted and said abortion is great, and then they came back and added abortion is good, and then it got redirected back to the article. Now, one thing we saw is that if we look at the timestamp at the bottom, this mass deletion happened on 17th of December, 4:06. It got fixed on the same day at 4:07 in 1 minute. And we were very curious. We were like, how is this happening? In fact, it happened so fast that if I do the same visualization by real time, we don't even see the gaps anymore. The reason why this is happening so fast, that it's being restored so fast, is because Wikipedians have a watch list. And you can add any article to your watch list, and then you can go back to the article and see if people were editing in good faith or vandalism, okay? The last thing I want to show is the chocolate page. So this is the article on chocolate, and when we do it by versions, you have this beautiful zigzag pattern. In fact, I look at this and I'm like, I have to have a dress that looks like this. But what this is, the zigzag, is an edit war. Okay, someone is adding a piece of text and someone else is taking it and then adding and taking. In fact, I can show you. Back then, someone added one paragraph in white that says, extremely rarely, melted chocolate has been used to make a kind of surrealist sculpture called collage. Well, a few times later, someone came in and said, removing Boyer invention. Well, Daniel Boyer comes back and says, reverting. Collage is not a Boyer invention. Google search for collage finds only Boyer. Reverting. Leave your humbug out. Reverting, and so forth. And so eventually Daniel C. Boyer gives up. It's like, forget you all, which is unfortunate because it turns out that chocolate collage does exist. We found it on the web, but such is life on Wikipedia. But it's interesting that the visualization would show you these patterns. Another thing we did was to get rid of all the color from authors and just make text darker the older it is. And this way you can see that there are a number of passages of text that are quite old, right? The darker they are, the older they are. Why does that matter? It's because this is probably a proxy for quality, for the quality of the text on Wikipedia. And so just to wrap up on this, by doing this work, we were able to not only visualize Wikipedia, but we were able to start seeing some dynamics that we could see throughout the website. So for instance, the fact that those corrections for mass deletions were happening so fast, within minutes, we analyzed all of Wikipedia and found out that mass deletions were being fixed within 3 minutes, under 3 minutes on average on Wikipedia, which is pretty impressive. All right, so now let's keep going. And because of how I'm doing on time, I think I am going to, okay, I'm going to try to go very fast. In 2010, I believe, Martin and I were asked this question: how do you visualize a city? In this case specifically, it was Boston. It was our own city. And we decided to go back to photos. So we went back to Flickr. Remember? That was a long time ago. And we decided to download all the photos from the biggest park in Boston, which is called the Boston Common. And we got only the pictures that were released under Creative Commons license and were available for public use. And then what we did is we bucketed these images. We wanted to show Boston over time, over a whole year, because Boston is very seasonal. We have wonderful fall foliage. We have great springs. We have very cold winter. And so we were wondering if we could capture those changes during 1 year just by looking at the images of the park, okay? And so we bucketed all the images, say for January, for February, for March, by month. And then what we did is we extracted, it's almost like we squeezed those images into color. And we just got each color in our color cube in the color space. And we started filling those buckets. The more you had of pink, the bigger the pink bucket would be, and so forth. And then once we had that information, we decided to lay it down over a whole year, okay? And so this is what Boston looks like over a whole year, with starting at the bottom with January. So January is at the bottom. You can see lots of gray here. We start, if you go clockwise, we start towards the top left. You can see some fuchsia, some magenta coming up. These are the flowers in the park that are starting to bloom. You can start to see like a bulge of greens. That's, again, the foliage coming back and wonderful greens on trees. If you go all the way to the kind of like bottom right, you start to see the foliage colors that are so typical of Boston. So you can actually see this beautiful flow of nature and of colors, right? And even though it looks very flowy, when we cut the seasons at their top, you can see the distribution of colors is quite different from one season to the next. All right, and then and this is what it ended up looking like on the magazine. So this was the Boston magazine that came to us and said, please visualize Boston. And we're like, what are we going to do? And eventually we decided colors was the way to go. Okay. The last thing I want to talk about is when you want to visualize something that is truly invisible. How do you do that? So in this case, we were interested in wind. And it turns out that wind has quite the history of being visualized. The map you're seeing at the very bottom here is by Sir Edmund Halley on trade winds. It's a beautiful, I think it's a beautiful map. And then you see a couple of maps at the top that are kind of like vector fields, right? Which makes sense. You want to aggregate a bunch of sensor data, and then you want to show the direction and the force of the wind. And that's fine, except that Martin and I kept scratching our heads and thinking, but this is the web. We should be able to do something a little bit more dynamic than vector fields. And after many, many iterations, believe me, we almost gave up on this project because we were so stuck. We came up with a new technique. And by the way, this is all due to amazing government public data. So all of the data that we use to visualize wind for the US specifically comes from NOAA. It's public, it's live data. They rely on a grid of sensors, sometimes from volunteers, sometimes it's all government data, and it covers the entire US territory. All right, and this is what the visualization looks like. So this is actually a website that anyone can go to. You can go to the WindMap website. It's always running and showing you live data. Because I did this as a little movie, we are looking at wind data from March 2nd, earlier this week. But you should be able to just go and see the wind right now for yourself. And one of the things that was so interesting to us is all the different patterns you get. You get large, really large patterns, and then you get very delicate patterns, like this is over the mountains. And you can see like it's almost a lace-like pattern. And then it changes from day to day, so much so that we decided to create a gallery so you could start to see some of the different days, what they looked like, and how much the wind changed. So for instance, I'll show you some of the different days here. So this day that's coming up here was a day when, you know, Canada was stealing all of the wind from the US, all of the air from the US, right? And not even the mountains were getting in the way there. Another day here, the wind was kind of parting the country in half and going in almost coming together into very different diagonal directions. And then there are days like this one, which are quite dramatic. And what's happening here is that this is Hurricane Isaac making landfall. And on this day, because remember, this is live, we started getting emails of people who were sitting in New Orleans and saying, I'm looking at your visualization, I'm praying that this thing passes and that we don't get hurt. And it wasn't until, and that was very powerful. And it wasn't until we were on the way of a hurricane ourselves, this was Sandy making landfall, that we realized just the power, obviously not only of the wind, but of having this record and having this live data show you and show the world something that is happening right now in your backyard. And so let me see if I can move on. So again, this is exactly the same data you saw before on vector fields, but because we're not aggregating a ton, you can see a lot more detail. And I claim that because you can see a lot more detail, it's much easier for your eyes to actually resolve the patterns in this visualization, which is not super intuitive. Usually we try to simplify things. But because we're not aggregating a ton of data here, we're just showing you and letting it flow with your eyes. I think, again, our brain can resolve this much better. We started getting a ton of feedback on this visualization. So for instance, farmers writing to us and saying, I look at your visualization before I spray my crops. Scientists, teachers who sit with students and look at the map and try to forecast the weather. Pilots, both commercial and private pilots, and military pilots wrote to us saying, we're looking at the wind map. At which point we said, oh no, please don't. This is like an art project. This is not like, please do not use this to fly your airplane. In fact, we were so concerned because we got so many emails from people who were using the map for very serious purposes that we put a disclaimer. We said, please do not use the map or its data to fly a plane, sail a boat, or fight wildfires, because we were getting those emails. To which we got emails back like this. Yeah, I get your disclaimer, but please respect the power of this visualization in promoting the prevention of wildfires. And so that was a very humbling moment because it showed us that once you unleash into the world live data visualizations, people will appropriate it in really interesting ways, right? In fact, after we created this technique, media outlets around the world started using the technique to actually visualize wind in professional ways, which was really interesting, really cool to see. And it's also part of the permanent collection of the MoMA in New York. And to me, I just want to finish on this note here, which is, again, we use data visualization because that takes advantage of something we're really good at, pattern seeking. I also think about data visualization as a gateway drug for statistics. Again, you don't need to have a PhD in statistics. You just see these patterns. Because of that, it broadens the set of people who can engage with these large, complex data sets. And finally, it really helps raise the overall level of data literacy, which I think is super important. I will stop there and thank you so much for your time.
Thank you, Fernanda. That was amazing. That was very beautiful to the eye, indeed. So we received a lot of questions, so I'll start quickly with them so that we can go through most of them.
Sure.
So the first question is, which tool did you use to visualize the version change of the article over time?
We created it over ourselves, and it's so old that we created it in Java. It's all Java. It's a Java application.
Is it available by any chance?
It's not available, it's unfortunately, but it's very easy to create. If anyone wants to recreate it in JavaScript, that would be an awesome project.
Cool. Second question. What is the current research in data visualization and where do we head to?
So, as I said, my team right now is working a lot on visualizing artificial intelligence systems. There's so much we don't know yet about those systems, and I really think data visualization is uniquely positioned to help us. Another thing, so that's one thing, is AI systems, all the range, and I think data visualization can be super useful. The other thing I'm very excited about is text visualization. Like, again, when we stop thinking about numbers and we think about other kinds of data that we produce, text is huge and it's so hard to visualize. And yet now, because of these AI systems, we have new ways of understanding and of reading tons of text. So it's wonderful. We can start visualizing text in a whole new set of ways.
Interpretation changes. So I think the next question, are there any books or other sources about data visualization that you would recommend?
Yes. Oh gosh, many books. So a few authors, if you're interested. One is Alberto Cairo. He's a journalism professor in the University of Miami. Another one is Isabel Meirelles. She's a professor of design, and she has this wonderful book on design for data visualization. And then finally, the last one, Nathan Yao, who has both a blog and a number of books on data visualization. I really like all of them, all of those authors.
Nice, thank you. Maybe this is a bit repetitive. What are the best methods for visualizing large amounts of data? I think that you already kind of answered this one. Based on your research with the Wikipedia dataset, were you able to provide relevant, useful feedback to the Wikipedia community, in addition to the data visualization, of course?
That is such a good question. So it turns out that we were in touch with the Wikipedia, because when we saw those things being fixed in minutes, we're like, how? That doesn't seem possible. So we reached out to them. We're like, we're seeing this thing, and is that true? And they were like, oh yeah. And they were the ones who explained to us about watch lists. So we shared with them the work we were doing. And in fact, Jimmy Wales, the CEO of Wikipedia, he really wanted to have so the visualization is called history flow, and he really wanted to have a history flow diagram for every article on Wikipedia so that people could understand what's happening. But unfortunately, neither Wikipedia nor us had the resources to just make that happen at the scale of Wikipedia. It's mind-boggling. So we never did it, but we shared the work with them. They know about it. They, saw the diagrams. They were very excited. And I don't know if it was because of the diagrams, but the edit wars that I showed, the zigzag, some of them would go on forever. And then after a while, they made a new rule that you could only revert back and forth 3 times. So those zigzags became much, much shorter.
The question there is, on which version do you end after
Yes.
the Thank you. Another question is, what were the tools and languages that you used in your amazing wind visualization?
So as I said, we almost gave up on that project because we were so stuck. I have a whole talk just on things we tried for the WinMap that were big failures. And all of those failures, all of that exploration happened in Java because Martin and myself, we like Java a lot. But then the final WinMap was done in JavaScript so that it could run on the web and anyone could see it anytime. So.
Nice. What are some applications of visualization in Google products?
Oh, there are numbers. So for instance, our team has worked with, for instance, Google Analytics. So Google Analytics has a visualization we helped out with that shows you, especially if you are a big, complex website, where people are getting stuck and where people are dropping off of your website. What are the flows that people take through your website? What are the main paths? Another visualization I really like that we did is if you use the Google Dictionary, if you just type define and then a word, define mortgage, you can see the visualization of the etymology of this word. You can see how it changed over time until it became part of the English language. And this is a visualization we created. There are a number of different visualizations in Google products, yeah.
Thank you. Maybe one last question, as we are over time already. Would visualization provide any help for better learning or training for machine learning models?
That's interesting. So the way we usually have used visualization in machine learning is to better understand, is through AI interpretability. So it's to try to understand what the system is doing. We haven't tried to use visualization to help the machine learning system. Well, okay, let me take a step back. Once you better understand, once you can visualize what's happening inside these systems, then the next step, obviously, is if you have a problem with these systems, if you have to debug these systems, the visualization is super helpful. So in that sense, yes, the visualization helps make the system better because it gives you kind of an X-ray of the system, and then you can say, oh, this here is a problem. Let's work on this. So in that sense, yes, for sure. We have used, and by the way, most of the work that we do in pair at Google is open sourced. So these visualizations, there's something called the embedding projector. If anyone is interested in looking at visualization for these massively high dimensional spaces, please check it out, embedding projector.
I think that's available.
It is available and it's open source. Yeah.
It's open source. Yeah, great. Thank you very much. Yeah, this was very insightful. Thank you very much, Fernanda. I hope everyone is now more inspired at looking at patterns and seeing patterns in their data.
Yeah, me too. Thank you. Thank you so much for having me.
Thank you for joining.